This presentation ex- speaks to how a chilled water circuit operates and the components of such. The purpose of the chilled water pumps is to circulate water flow in pipes back from the chiller to the air system's cooling units and back to the chiller. This water flow is designed to match the required flow rate of both the air system cooling coils. All types of pumps are now usually installed with circuit balance valves, CBVs, at the discharge of the pump. This allows water flow for the chilled water air conditioning system to be measured and balanced to design flow rates for the chilled water air conditioning system. The pumps must be in operation for the chiller to start. Water flow is expressed in US gallons per minute or liters per second. Pump discharge pressures are expressed in PSI or foot head. This system is complete with a chilled water circuit expansion tank. The expansion tank allows for fluctuation in the volume of water in the system as the water temperature changes. Under normal operating conditions, the tank level should not rise above the top or drop below the bottom of the sight glass. The sight glass is mounted on the side of the expansion tank. Chilled water circuit components. A compressed air line connection is provided to the water expansion tank, which allows for pressurization of the expansion tank. If the expansion tank installation is correct, it will serve three purposes. It will maintain the chilled water air conditioning system circuit at the design pressure. It will provide a positive head on the suction side of the circulating pumps, ensuring air is not drawn into the system. It saves wear and tear on the pumps during startup. The make-up water system consists of a bypass valve, shut-off valves, and a pressure regulating valve, PRV, or commonly known as a water make-up valve. One side of the system is piped to the domestic cold water system, and the other side is piped to the water expansion tank at the suction side of the circulating pumps. If the PRV malfunctions and allows more makeup water into the system than necessary, then the pressure relief valve will open and allow the system to drain until the excess pressure is released. The relief valves are each set above the chilled water air conditioning system. System design, operating pressure, and should not be adjusted. The shut-off valves are used to isolate the PRV should it ever malfunction. The bypass valve may be opened manually to add water whenever the expansion level drops too low or until the PRV is repaired and put back into service. Double check valves are provided at the domestic cold water line connection to the PRV to prevent chemically treated water from entering the cold water system in case of return flow. Chilled water circuit chemical treatment. The chemical treatment is necessary to ensure there is not premature deterioration of pipes, pumps, valves, and coils. Chemicals necessary to treat the chilled water may be added manually or automatically. It is usually a manual function in most applications. However, on more sophisticated systems, water may be automatically tested and chemicals added automatically. They may be added to either the chilled water supply or return lines. It is suggested that chemical tests be performed on a weekly basis to determine chemical concentration, and that conditions be maintained as directed by a chemical specialist. Chemical treatment is necessary to inhibit rust and corrosion of the water side of all chilled water pumps. There is also an excess pressure control loop. A water pressure control, which is a bypass automatic control, senses the differential pressure between the supply and return line. It is provided to maintain a constant pump head pressure at the circulating pumps. It is also known as pressure compensated flow control or a pressure regulated volume control. The control positions a normally closed two-port valve towards the open or closed position. It responds to increases or decreases in differential pressure in the cooling system. The increased pressures developed at low cooling demands must be controlled. The bypass control valve is located in a crossover pipe between the supply and return water lines. This crossover may be located at the pumps or at the end of the supply and return line. Thank you very much for listening.